Ch02-02 problem can be solved using a graphical method. A graphical method is a method for solving linear programming problems with two variables, and it happens that our problem has two variables, right? It has x1. This variable indicates how many aqua spas we are producing, and it has x2, number of hydrolux tubs they produce. So to solve this problem graphically, we have to draw a graph with two axes. I will always put the first variable on the horizontal axis and the second variable, x2 in this case, on the vertical axis. And we also have to assume some kind of units. Now, because we have those non-negativity constraints, we will always, we will in this case not always, have values of x1 and x2 0 or positive, and that means we can just start from 0, 0 here and then draw only the first quadrant of the graph, so just positive values of x1, positive values of x2. But still the problem remains of how to choose the units. When you draw this graph, this kind of graphs, you will ask yourself what should be the unit. Should it be 1, 2, or 10, 20, or 1,000, 2,000, and so on. So in this case, what I did is actually I looked at the first constraint and notice from the first constraint I can see that x1 and x2 cannot exceed 200. Each of them, right, cannot exceed 200. That's because if you think about that, x1 can be at most, at least, it has to be at least 0, then x2 must be at most 200, right? The smallest value here is 0, so that means the highest value here will be 200. And then again, if I reverse this, if I put the smallest value here from this constraint is 0, then that means the highest value of x1 will be 200. So I put units 50, 100, up to 200. I put a few more. You'll see why actually I might need those higher values. So now what remains is, what we have to do is we have to draw on this graph, indicate which points are feasible solutions for this problem and which points are not feasible. And so feasible points are the points that satisfy all constraints. In other words, these are the points that are acceptable as solutions to the problem. Feasible means acceptable as solutions, acceptable in terms of those constraints. So we'll start from the last two constraints because they are the easiest to draw. So we will start with x1 at least 0. So how do we indicate these points? Where are those points? Well, first we have to ask ourselves, where is x1 equal to 0? X1 equal to 0 on the x1 axis is here. This is x1 equal to 0. Here it is higher than 0, here it is equal to 0. So points with x1 equal to 0 are all on this vertical line, which overlaps exactly with the x2 axis. And this is something that some of you might find surprising, but x1 is 0 on the x2 axis, right? And what is x1 higher than 0? We want greater than or equal to 0, so greater will be to the right of it, right? So this is x1 greater than or equal to 0, right? Now if you consider what is x2 greater than or equal to 0, right? So let's see, x2 greater than or equal to 0. Again, we will ask ourselves, what is x2 equal to 0? Well, x2 is equal to 0. This is x2 axis, and then it is equal to 0 here. So again, points that satisfy x2 equal to 0 are all points on the horizontal axis, on the x1 axis, and then they are higher than 0 above this axis. So this is ours. This is our x2 greater than or equal to 0. Okay, so we did the last two constraints, the non-negativity constraints. Now let's try to draw to indicate the points for feasible points for the other three constraints. So let's start with the pumps. And so again, we will do the same thing. If we want to see where the number of pumps used, x1 plus x2, is less than or equal to 100, we'll first ask ourselves, where is x1 plus x2 equal to 200? What is it equal to 200? Well, this is a linear function, so its graph will have will be a straight line, and to draw a straight line I just need 2 points. So the easiest 2 points will be if I assume x1 is equal to 0, then I can say what is x2? Well, if x1 is 0, I plug 0 here, so I have 0 plus x2 equals 200. So x2 is just 200, so I just have a point, right? x1, x2 is equal to 0, 200. I have a point in 0, 200, 0 on x1, 200 x2. This is the point. And then I need another point, and another easy point will be when x2 is equal to 0. Then I will have x1 plus 0 equals 200. So again I have a point, right? I will just write it like this. I have a point 200, 0, right? I will always say this is x1, this is x2. Keep those coordinates in order. So 200, 0, it's this point. So points that are x1 plus x2 that satisfy this x1 plus x2 equals 200 are points on a straight line between those two, or right, going through those 2 points. Here is the line, and points, now I need to know points that are less than or equal to 200, for which x1 plus x2 is less than or equal to. Equal is on the line. Where will be the points that are less than 200? Well, it will be the points that are below the line, and we can check this by taking any point below the line and seeing and checking whether the sum of x1 plus x2 for this point is more or less than 200. So for example, if I take a point, a nice point here is 0, 0. This point, if I plug 0 plus 0, 0 plus 0 is less than 200. So that means this point satisfies this constraint, and in that case it proves that all points below the line will satisfy this constraint. So we know now that pumps, the number of pumps is less than or equal to 200 when the solutions, for those solutions that are on this line or below this line, right? This is for pumps. Okay, we have 2 more constraints, so let's delete this. So labor constraints, labor constraint, we'll take second constraint. Labor hours that is used must be limited to maximum 1566. So how do we find points that satisfy this constraint? Again, as before, we have to ask ourselves, what is 9x1 plus 6x2 equal to 1566? Well, again, as before, we can try to find 2 points and draw a line that satisfies this equation. So we can do this by saying x1 equals 0, and that means if x1 is 0, we have 6x2 equals 1566, and that is when x2 is equal to 1566 over 6, which is, I can get the calculator, 1566 divided by 6, it's 261, so the solution here is 261. So I have a point here which is 0, 261, and this point is somewhere here, 0, 261, and then I can try the same, x2 equals 0, and that will give me 9x1 equals 1566, and that means x1 is equal to 1566 over 9, which is 1566 over 9, 174. So it's a point, this is exactly 175, it's just to the left of this 174. So again, I need a straight line that goes through those 2 points. Okay, there's the line. And now I need to again ask myself, well, this was equal 1566, so the points on the line use exactly 1566 labor hours. Which points use less than this? Well, again, as before, the points to the left or below the line will use, right, less than 1566 labor hours. So I'll just write here, this is labor constraint, okay, and this is this line or points below, right? So I have already a total of 4 constraints, the 2 non-negativity pumps and labor, and the last one that I need to do is the feet of tubing. So let's delete those parts. So for the feet of tubing, this is the constraint that we will be now drawing. So I need to again ask myself, where is 12x1 plus 16x2 equal to 2880? Draw a line. So x1 is equal to 0, then 16x2 equals to 2880. So that gives me x2 equals to 880 divided by 16, which is 2880 over 16. That's exactly 180. And then if x2 is equal to 0, then I'll have 12x1 equals to 880, and that gives me x1 equal to 880 over 12. That's x1 equal to 240. So I have the first point is 0, 180, oops, and the second point is 240 and 0, right? 240. So 0, 180 is somewhere here, and 240, 0 should be somewhere here, right? 240, 0, 0, 180. So again, I need to draw a straight line through those 2 points. Let me try and draw it. Here it is. And again, as before, I have to ask myself, where are the points that that use less than the maximum 2880 feet of tubing? And as before, right, as before, these will be the points that are below the line. So this is an example tubing. This is an example of a problem where we have only resource constraints, and all those resource constraints are of the form how many units are used, less than or equal how many units are available. It's not always like this in every problem. Sometimes we will have as the line of the constraint will go from left to the right. It will go up, not necessarily down, and it's not always below or to the left to the line where the points are feasible, but in this case this is what we have. So if I redraw this all this using PowerPoint, that's how it looks, and I have now all 5 constraints have been taken into account, and you can see 3 lines plus the axis. These are the 5 lines that limit the feasible points. So the question now we have to ask ourselves is, where are the feasible points for all those constraints, right? Each of those lines says, for labor, this is feasible points are on the line and to the left of it. But for all of those constraints, if we want feasible points, we have to take the set of points that are common for all those half spaces, half planes, right? Each constraint, if you think about it, each constraint is like this. Each constraint is some kind of line, right? Like this, some kind of line, and one side is feasible, right? And the other side is infeasible or unfeasible. And then the line is also feasible, right? The line is also feasible. So for all of those constraints, we have something like this. Now the line can have different slope. It could be like this, right? It could be like this. It can be a horizontal line like x1 axis, or vertical line, right? There are all kinds of possibilities, and for these lines we have to find the common set. We have to find the common set for all of those lines. So what are the points that satisfy all those constraints? Well, these are the points that I can mark with this blue region, right? This is the point, the set of points that are common to all the 5 half planes. So this is the set of feasible points. I can say this is the set of feasible points, right? These are the feasible points. So the blue region, we call it feasible region, or set of feasible solutions. There are a few other names, right? So these are all points that we can use as solutions, right? These are all points that we can use as solutions. But from what we used in this model is we used everything except for the objective function, right? The constraints tell us basically what's possible, and now we know what's possible. All the blue points inside or on the boundary are the points that are possible solutions, feasible solutions. Now we have to choose the one that maximizes the profit, right? The best point is the one with the largest possible profit. So I'll show you in the next episode how to find the largest possible profit.